Hi, Yukon. Can you hear me? Hi, can you hear me? Okay. Hi, Jackson. How you doing? Hi, everybody. Welcome. Oh, no. All right. Let's see. Welcome back. Welcome, everybody. Come back from a weekend and beginning of midterms. Let's see where we are. Yeah. So let's see. We did the quiz last week. I mean, the exam we reviewed earlier last week, and then we did the exam later that week. We and so we're a little bit over the halfway mark for the semester. Uh, Up to this point, we've been discussing mostly front-end technologies, HTML, CSS, JavaScript, React, Redux, state management on the client side. So for in the second half of the semester, we're going to be focusing much more on the back end, right? On the middle tier, the database security, maintaining state on the server side. So that's going to be more the focus for the next couple of weeks. We're still definitely going to be integrating with the front end. Right? We're still going to need the user interface, but instead of the user interface just running on a browser, and now it's going to be able to reach out to third-party resources. Go out to the server, go out to a database and retrieve data, right? And maintain state across multiple requests. Okay. Yeah, so that's going to be the next several weeks. The you should be already having identified some teammates and thought of what you might want to work on together, and perhaps started prototyping a few things, maybe a couple of pages, uh, perhaps static pages, maybe styled it, perhaps even started with a few React.js components, and how to dynamically render some data, perhaps created some static JSON files that represent the data you want to render, and played around maybe some navigation between the different screens. So you already have all that knowledge, all those skills you do have, and in a project working together with other folks, definitely it's a great place to practice that further, but on something that you choose as opposed to me asking you to implement something specific. So yeah, so definitely you should start making progress towards the project. Please don't let this take much longer. Leave it to the end. Definitely the end of the semester is going to become pretty hectic. You have many other things that are also due towards the end of the semester. So, any investment you can do right now, right, it's going to pay out later. All right, so let's focus on the server side, the middle tier. Today we're gonna implement a server using Node.js, and we'll see that it nicely complements the client application that we've been working so far, right? The React application that we've been implementing suffers from several handicaps, right? It's even though we can create a dynamic user interface that we can click and things change, we can add content, remove content, update content. Those changes go away once you refresh the screen, right? If you do a Control-R, refresh the entire browser, we see that all those changes go away, right? There's no place to put that in those changes make them permanent, right? So today we're going to introduce Node.js as a server, and later next week a database, right, to be able to make those changes permanent, right? We'll first work with the server side. Where do we store this? We need to set all this information over to something that can run 24/7, right? Can receive data, retrieve data, right, and store it in a permanent place. Right? So first we'll look at the Node server, just storing it in its own memory, right? We'll just use simple data structures such as objects and arrays running on a server, and then the client, going to fetch data at the server, as opposed to storing relying on JSON files on the client side, right? It's going to rely on data that it gets from the server. Okay. Yeah, so that's going to be the focus next this week. A8, I'm still making a few tweaks. Please do not start A8 just yet. Okay, so please don't go ahead. I am going to cover the material you need to complete the assignment A8, but I'm still making a few tweaks here and there based on where we've been so far in the assignments, where we are right now, and so I had to change a few things. So please don't start that just quite yet. And anyway, the assignment 7 was moved to this Sunday, right? So you still have time to complete A7 since we had the exam in the middle, and I want to give you some time to prepare for that. The assignment 7 due date has moved to this upcoming Sunday. Yeah, so no, don't start A8 quite yet. All right, let's see a few questions. A8 Node assignment available? Yeah, please, it is available. You can take a look at it, but I am making a few modifications. I'm editing a few things. Again, please do not start on A8 just quite yet. All right. You can peek, take a look at what's going on, but I'm making a few changes. Yeah, please don't get started. All right, so let's get started with server. Okay, let's see. There's a few slides here, although I'm going to code most of what I'm going to be displaying, but here's a graph, just a little bit of the architecture of what is it that we're building. Right? So we've been spending most of our time here on this box, this first box, where you have the client browser, right, that runs on your desktop, goes and fetches, HTML, CSS, JavaScript, and it all executes on the client side. So what we're going to be focusing on this week is this box over here, right? It's going to be a server that's going to run on some cloud computing software such as AWS or Heroku or whatnot, right? And this is going to be running 24/7, where we are going to be able to send data, retrieve data, so that it can store it somewhere. Right now, this week, we're going to show you how to store it on the server itself. Right. Next week, we're going to introduce how to store it in a database. Right. Also running on a platform as a service. Okay. So yeah, so this is the architecture of what we're building. This is oftentimes referred to as a client-server architecture, and we're going to be focusing on this middle box here in between these two worlds. Oftentimes, this is also referred to as the middle tier, right? The middle layer, right? So that's what the focus of this week. Will we learn Firebase authentication? No, not Firebase. Although you're welcome to use Firebase if you want to play around with that. We will be doing authentication. We will be implementing just simple email password authentication using just Node.js from scratch, right? So we'll build that ourselves. There are services that provide authentication with username and password that allows you to log in, also using Google or Facebook or Twitter or any other third-party authentication. But that's not going to be focused. We do cover that in the software engineering course. We do cover Firebase and the databases and the various authentication services and data buckets and whatnot. But that's a completely different course. All right, so let's get working. Okay, so I'm going to fire up a PowerShell. And in here, we're going to move over to a directory where we can do all our work. Oops. CD, HN2, we have vault, and what the? And so right now we have a Twitter React app web application built using the React.js framework, right? So this implements the front end side, right, of our application. We're going to create a different application, right, that runs on the server. So this is going to be an entirely brand new application that is going to be standalone, right? It's not going to have any dependencies with anyone else other than maybe database later. And it's going to run on its own server. And the client, right, the application, this React application, later on we're going to integrate it, right, through HTTP requests, right? So we're going to be working on this part right here, this over here, okay? And the way we talk to it is by sending it HTTP requests, and then the server can respond with HTTP responses. Okay, yeah, so this is an entirely brand new application, its own directory, its own GitHub repository, running on a different AWS server. Okay, so to get started, we're going to create a brand new directory, and we'll call it Twitter node server. Right. This is this fall. Okay. So let's go in that directory, and right now it's empty. There's nothing in it. Okay. So to get started, we are going to create in this directory. We're going to create a node application. Right. React.js, the React.js Twitter React web app that we have been building has been a Node.js application all along. Right? But we didn't build it from scratch. We asked the Create React App module to create it for us. Right? It created a boilerplate template that implemented a React application. Here we're going to build a Node application from scratch. Right? So notice that this directory is empty, and we can use npm, right, which is the Node package manager, the same tool we've been using so far to install things, right, of different libraries, Express, Core, Bootstrap and things like that, right? So here you can also use it to initialize a Node application, right? Any Node application, this is how you would initialize it. So if you run npm init, it's going to ask you a few questions, right? And it's fine to just keep the default values. It's asking you what's going to be the name of this package, this Node application. It by default it chooses the name of this of the directory. You can give it a version. You can describe it. So this is a Twitter middle tier. Okay. Usually there's a file that is the entry point to this application. Index.js is fine. We don't have any tests. It's not in a Git repository just yet, so we don't know. It is going to be in a Git repository, but we don't know what it is just yet. Keywords, we'll say Twitter, social network, web dev, Eastern. Okay, author, C, license. Okay, so it creates for us this JSON file with this content, right? So some keywords, the author, the license, the script, the name, and whatnot. And say yes. And what it does is it creates this file, package.json. And this is what describes this project, package.json. All right. So now we can create our Hello World application, Node.js application. Let's open it up with our favorite. With our favorite editor. Okay. Let's say file, open. Machine's a little slow today. Open. Let's see. Full web dev 610 and node server. There it is. Let's say okay. And let's create a simple hello world file here. JavaScript hello. Yeah, so in here we're just gonna say console log. Okay. So back at my command line, notice that now I do have that hello.js, and I can run it and say node hello, and it runs the command line, and there it is, hello world. So really, that's all Node is, right? Node, right? We installed it early on in the semester. It's just a JavaScript interpreter, and you can give it a JavaScript file, and it executes it here in the desktop. As opposed to, we have been using JavaScript exclusively, running it on a browser. And we have been stepping through it, breakpoints. We have been implementing JavaScript files that implement, HTML components, right? That can be configured. It can read JSON files. It can iterate over JSON data, right, and render lists or tables or hyperlinks, right, or tabs. Okay, all for use on a user to implement a user interface, right, using a browser that reads all these JavaScript, runs it in the browser, right, and generates all the user interface dynamically. So what Node is a Node interpreter, is a JavaScript interpreter, right, that allows you to run JavaScript, but on a desktop, right, at the command line, as opposed to running it on a browser. That's all Node is. Okay. Now, one might say, well, what's the big deal? So the importance here is that we can by liberating JavaScript from the browser and being able to run it on a desktop, there are many things that you can now do on a desktop that you cannot do on a browser. On a browser, certainly you have a lot of capabilities. You can draw on the screen, you can interact with users with their buttons, as they click, as they move their mouse, or they type at the keyboard. Right? We have forms that folks can fill out. Right? We can render things on the screen, but we don't have a place to store our data. We can't access the file system. We can't get to a database. Right? We can't just willy-nilly talk to anybody on the network. So there are limitations when you run JavaScript on a browser that you do not have when you run it on a desktop. When you run JavaScript on a desktop, you have unfettered access to the file system. You can connect to a database. You can create network connections to anyone you want. Right? But you don't have the things that you had on a browser. When you run on a desktop, you don't have a user interface. You don't have the buttons, and you don't have HTML and CSS and none of that. Right? So this is an entirely different application of JavaScript. It's mostly for data processing, right? Working with data, transforming data, reading data from a database, storing data from a database to a file system, doing network connections, things like that. Okay, so you'll notice that a lot of the JavaScript that we're going to be writing today, right, for the rest of the semester on the server, right, will not have anything to do with keystrokes or button clicks or rendering anything on the screen. Right? It'll be about iterating over arrays and filtering, right, and doing network connections and retrieving data from a database, right, or inserting or updating or deleting things from a database. Right? So that's the code that we're going to be writing using JavaScript, right, on the server. So and what we're going to do is that we're going to have two JavaScript applications, one running on the browser, right, and one running on a Node server. And they're going to complement each other very nicely. They're going to talk to each other using HTTP. The client is running on a browser is going to send HTTP requests to the server. The server is going to process that request, right? Going to compute a response, right? And then sends the response back to the client. And the client uses that data to render the user interface. So you have this cycle, right, of where the JavaScript on the browser and JavaScript on the server complement each other. Right? The things that the user interface can do, the server can't. And what the server can do, the browser can't. Right? So they complement each other very nicely. As long as they know how to talk HTTP to each other, right, you're good. They can interact with one another. Okay, so there's our Node, our very first Hello World Node application. So let's do something a little more interesting. Okay. So let's create a small, tiny little server. So to do that, we're going to be using a library. It's a very, very popular library to create servers. Node is or JavaScript, just like any language, it's not very interesting on its own. What makes a library JavaScript a particular language or framework interesting is the libraries that have been written for it, right? The tools, the support, the community that gets created around that particular infrastructure or language, and certainly JavaScript has a great following, especially the Node.js community. There's been tons and tons of really great libraries, of which we've been using one of them, right? The Create React app by Facebook to create the React.js applications. Okay. All right. So let's install a library that is going to allow us to create an HTTP server. Right. We're going to create this HTTP server here, right? That can listen for incoming requests, right, and respond to the client so that we can integrate with it. Okay. All right. Okay. So let's see what we have here. Just nothing. Hello.js. Great. Let's create here another file. We'll call it app.js. It's a very common name for an application. And so here we're going to start loading a couple of files. right, or libraries. And the first library that we're going to be working with is the Express library. We do npm install Express. So smaller system, follow along. Okay, it's done. If you notice, if you go to package JSON, you'll see that a new entry has been made. There it is. It's a dependency, meaning our application depends on this library that it's installed. If Express is not installed, then our application will fail, won't run. Okay? It's important that you check to make sure that these dependencies are listed in the dependency property of package JSON, because this eventually is going to be deployed in a remote server. And the remote server, either Heroku or AWS, it's going to read these dependencies and it's going to install to make sure that your application has everything it needs to run. Also notice that since we installed Express, a new node_modules directory was created that contains all the libraries, including Express library plus anything that the Express library depends on, right? So npm just loads all the libraries that depend on each other. Okay. All right. So now that we have it, we can import the library. So by default, the Node.js does not understand how to work with imports. Okay. It uses a different way to load libraries. It's a different syntax. So for instance, if we want to load the Express library, we use a different syntax, right? Here we would say something like import Express from blah, blah, blah. Right? So an equivalent mechanism for doing that is not ES6, right? It's before ES6, is to use the require function. The require function searches for a library and it loads it into memory, and then it assigns it into a local variable or constant. So in this case, it's the Express library. There it is. It found it. It's looking for these libraries in node_module. So if you don't put anything in front of the library, then it looks for that name under the node_module and it finds it. It's there. There it is. Yeah. If instead you put a / in front of it, then it looks for the file locally, right? Starting from the local directory, or you can say .. if you want to go up or down or whatnot. But if you don't put anything, if you don't prepend anything, then it looks in the node_module. So there's Express. So Express is a library that allows us to create these, allows us to implement these request response, HTTP communication back and forth from the client. It allows us to receive and send back responses. Right? It allows us to participate in this client-server relationship, right, between our clients and ourselves. So the way you use it is you first load it up, you create an application out of it by instantiating. This is the equivalent of a constructor or calling the Express, and it returns an object, right, that we can then use to implement this HTTP request response architecture. See the question in the chat. So will we learn? At some point in the lecture, can you show a simple example where you query an external API endpoint and store it in the local server? Yes, we will do that, absolutely. Yep, we will do that, absolutely. Yeah, so we have this Express library. We have an instance of it now. And then we can start doing things with it. We can say, well, we want to be able to listen for incoming requests. We say listen. And we can specify at what port do we want to listen for these incoming. So these servers, they run at different ports on a machine. Right? So your machine is tied to a particular IP address, which is unique to your machine. So each machine has its own unique IP address, right, in this worldwide internet connection. Yes? But even within that machine, you have many ports that you can connect to. So when you say, I want to talk to a machine, you also have to specify, well, which port in that machine. And there's thousands of ports. Now, some of these ports are very famous, and they have specific roles. So, port 22 is for FTP. Other ports are for email. Other ports are for FTP file transfer. Some ports are for browsers or HTTP servers that listen at port 80. So some of these ports are very, very famous. Okay? And up to this point, we've been doing the same thing. We have been starting our localhost servers, right, at port 3000. That's a very common port number for React.js developers. So because we know that we're going to be using port 3000 to run our React.js server locally on our machine, we don't want to collide with that server, with that port. So this one's going to be running at port 4000. So our server is going to be listening at port 4000. Again, we don't want to collide with the other server that is going to be running our React.js application that's running at port 3000. Okay. So what do we do when we're listening for 3000 at port 4000? We're going to be listening for incoming HTTP requests. Right? So here somebody's going to be listening. This server is going to be listening at 4000 for an incoming request, HTTP request. Yeah. Now these requests have different forms. They are typically the most common types of requests are a GET request, a POST request, a PUT request, and a DELETE request. Right. There's a few others. There's PUT. Right. There's options. There's a few others, right, that we don't use. But the typical 4 types of requests are those 4. Right. They are verbs. They're also referred to as HTTP verbs or HTTP methods, right, that distinguish on the intent of the request and whether you are requesting data, getting data, whether you're sending data, posting data, whether you are removing data from the server, right, or you are updating data that is already there. And so those 4 verbs, right, are meant for different intentions, right? What is it that the client wants the server to do? The client is requesting the server to do something. It says, hey, server, please send me data. Right? So the client would send a GET request to the server. Or the client is posting data. It's saying, hey, server, here is some data. So this client would post data to the server. Or the client might say, hey, that data that it's there, please remove it. And so they would send a delete request to the server. Or would send a PUT, right, to modify some data that is already at the server. So these are the more common, kind of CRUD operations: create, read, update, delete operations that are very, very common when you have some kind of data source. Okay, so today we're going to learn all about that. So we want to say, hey, I want to listen. We say app.get. I'm going to want to listen for an incoming GET request. Right. So here what we're saying is that if the server receives a GET request, right, it can receive also a POST request. Right, it can receive a DELETE request. It can receive a PUT request. Right. We can tell it what to do. We can say, right, if you receive a GET request, then do the following. And the way we do that is by specifying a path and a function. These are all functions. Right? A path and a function. A path and a function. They all take the same argument. Okay. So the path, the function is what to do. What is it is where you implement what is it that you want the server to do. Okay, now servers up to this point, they've been just asking for HTML content or CSS content. Right? The client has provided a path for a file that it wants. Right? For instance, if you say public here and you say labs or 5, right? You go and ask for this HTML and you run that. It's like I'm running a little server here, and this is the path location of that document. And so servers work with providing or identifying the things that you want. In this case, it's a file. You identify it by providing its location, right, on the file system of the server. Okay, so servers basically receive the paths of things that you want. Up to this point, these paths have literally meant a physical file. They have been mapped to a physical file. This URL /public/labs a5 index.html refers to a physical file that lives on my file system. All right. What we're going to introduce today is that we're going to abstract this idea of the path. Instead of being mapped to a physical file, it's going to be a logical symbol, right? A logical location for us that uniquely identifies something. Okay, and it could be whatever we want. It's arbitrary. It's very much like when we implemented the navigation, where we created routes, right, routers, and said, if you see this in the path, right, then render this component, okay? And then we implemented our own navigation because we wanted to override the basic underlying mechanism for navigation. We wanted to implement our own, because we introduced things such as the single page application. So we had to override and implement our own navigation on the user interface. So we're going to do something similar on the server side. The default understanding of asking things from a server, at first was asking for a literal file, and these paths meant, at first, it meant an actual file. But here we're going to do something more generic. We're going to say, if you ask for hello, notice the slash here, right, which refers to this slash here, right? The beginning of the slash of this URL. Okay, so meaning that I'm going to ask for something that starts with hello, like that. Now, does that map to an actual file called hello? If I say enter, notice that no, it doesn't match to anything. It doesn't match to an actual file called hello. There is no such file called hello. So what we're going to do is that we're going to say, okay, well, when it comes in, then we can compute what we want to happen when that request comes in. So instead of literally going to look for a file called hello, we're going to be able to calculate that response, right? And then respond whatever we want and say, we want to do something. We can do console log hello. Okay. All right. So let's try this out. We can run this and say node app. Right. Notice that nothing happens. It didn't print anything, and that's intentional. This starts a server that is now forever listening at 4,000. So let's try it out. Let's bring a browser, and let's try his local host listening at 4,000, and let's do hello. Notice that indeed it printed hello to the screen, to the console. See that? So our server is up and running, and every time it sees this request, right now it's busy. But the server will have to probably start a brand new localhost. 4,000. Notice that it's kind of stuck in there, waiting for something. What is it waiting for? It printed the hello. Notice that it printed for every request, for every request that it sees 4,000 hello, right? Prints another hello. But notice that the browser is kind of like spinning. What's going on? I mean, the server did what it needed to do, but the browser doesn't know that the server did what it's supposed to do, and it's kind of like forever waiting. That's because it's stuck on waiting for this response. The server never generated a response. The intention here is that the protocol or the structure of communication is that the client sends a request and then the server sends back a response. And here we broke that. We did not follow that structure. We only sent the request. The server did some work, right? It printed a console, but it never responded to us. How do we do that? I'm just going to do a cancel there. So to be able to participate in this, receive the request and then respond something to this function accepts a two parameters, request and response. These two objects, right, the request and response parameters, are passed in by the Express library when it receives this, right? And it's about to execute your function. It's about to execute your function, and it passes you a request response. So this request object represents everything that is coming from the client. It represents all this. Whatever the client sends us, it will be in the request. Right now, we're not sending anything, right, other than this /hello. So this URL itself, the name of the path, that is part of the request. Right? But there's tons of other things that are passed in. What time it was, what IP address it came from, right? Some authentication stuff from the client, So that would be all embedded inside of our request object. Right now, we don't need it. But let's look at the response. The response allows us to generate a response back to the client. So for instance, instead of doing console log, you can say respond dot send back this hello world. Right? Port browser is waiting for you to respond. Here it is. Here's our response. Hello world. Let's try it out. Let's restart the server. And so let's try this hello again. You notice that this time around, the response did come back. And the server did respond with a hello world. Make sense? Ever still with me? All right. Now this path is pattern matching. It's pattern matching, parsing the URL, pattern matching this URL and seeing what does this match with all these URLs that I put in here, right? So if I say get hello, and it responds with hello. But if I can have multiple gets, this could be goodbye. Right? It says goodbye. Goodbye. Oh no, that's too sad. Say life is good instead. So let's start the server again. Stop. You have to restart the server, right? Otherwise, it's running the old version. Let's run the server. So we go back here. Hello still responds with hello, but goodbye responds with life is good. Everybody good? All right, excellent. And we can implement some really simple operations. We can say, when I add a few things, we can say add. And so adding would mean that we need to pass in some kind of argument, right? Some kind of parameter that you want to add. Now, there's a few things that how we can send data to the server. Well, there's basically three. One of them is to embed the data as part of the path. So for instance, we can say add, and we can say that we're going to encode the data of the two parameters that we want to add as part of the parameter of the path itself. It's going to be embedded in the path itself. So for instance, this :A means that this is going to be a placeholder. It could be anything. We can pass in whatever we want. Right? It could be numbers, it could be integers, it could be strings, it could be whatever well, not objects. It needs to be something that can be parsed as a string. And then we can pass another one, we can pass in B. Okay. Now, this is a requirement that it starts with /add/ followed by anything / followed by anything. Right? And we can retrieve the values of A and B. We can parse it, the actual values of A and B, from the parameter. And say const A is from the request. So the request parses this from the path, right? And it creates for us a params map that contains all the values that were parsed from here, right? And so we would say .a. And so .a is a dot notation of a map, or we can use the other notation using params, the square bracket notation. Either one works. Okay. So for now, let's we can calculate C being A B, and we can send back the value. We can send back a string that says that A plus B is equal to C. Okay. All right, so let's try that. Let's run the server. And we say add 2, 3. And 2 plus 3 is 23. Obviously, what's happening is that it's interpreting these as plain strings, and the plus is as a concatenation. We can parse this as integers, parse it as an integer, and parse this as an integer, parse a double. And now this plus is going to be interpreted as a arithmetic addition. There we go. All right, everybody good? All right. Okay. So now, so this is getting pretty big and unwieldy. Okay. So let's move this elsewhere. Let's move this elsewhere, and let's move it to another directory. So let's move all this code here instead of just having it here. Let's put it in another directory. Now a collection of these guys, right? So gets and posts and puts together. They're doing something in common. They're referred to as controllers. As for instance, these are all like some examples. So we'll call maybe the examples controller. Right? We're just playing around with how to use this. So let's create a directory here and call it controller, and we'll have here the examples controller. So the JavaScript, the examples controller, and we're just gonna move all these into the. Okay. Now the problem for this is that we don't have app here. We don't have app. So somehow we need to get app in here. So what we'll do is that we're going to grab that controller, the examples controller, acquire that file. Now we have to do ./. See that? If we want to navigate a particular file or JavaScript that we recreate, we use ./. Controller, there it is. But just like we had in import and exports, we need to be able to do the same thing here. But we can't use import and export. So how do we do that? So instead, we do the following. There's an equivalent syntax, right, called module.exports. That whatever you assign to this, it can be required by other libraries. So this require only works if our controller assigns something to the module.exports. So what we're going to assign is a function like this. Function where we're going to put all this stuff in there. Put all that. Here we go. This is going to allow us to pass this argument, the app. See that? Be able to pass the app in there, so that when we have this controller, we can say controller, I'm going to pass the app from this guy over here. Okay. So now we have app. We're going to pass it when we call that function, and it's going to be up here, and then we're going to be able to run this. Let's try it again. Stop this. So this should work just the same. No changes. Oops, something went wrong. It says error. Cannot find module controllers. Require stack. Yada 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 yada. Module not found. Right. So it looks like it did not find it. So let's go to app.js. Let's see what we did here. Example controller require dot controllers. Controllers. I have to say which controller. So I guess we didn't say so. Controller slash and the example. So there. Let's try it again. Okay. Looks like it did not blow up. Let's try it out. So let's try 3 plus 5. That's 8. So it looks like it's working. How about hello? There we go. So it still works. It works just the same, right? But this allows us to break out large applications into smaller pieces. Everybody good? All right. So it'd be nice if we could use the old syntax. So let me show you. We can add that so that we can use the same syntax we've been so familiar with. But I did want to introduce you to that somewhat older syntax, but it's still widely used, the require, module express, and whatnot. Right? So you should be familiar with it, even though that's going to be the extent of what we use require. So we want to add ES6 support. And the way we do that is by changing in the package JSON. We're going to make it the type. It's going to be module. We're going to be able to load modules, right? Import modules. So back in the package JSON, anywhere here, we can put that type module. And so now we can use regular imports and exports. Okay. So if we try to run this now, it's going to fail. Because it's going to say, well, now I don't understand what require is. Okay. This was the old way of doing it using what are called CommonJS scripts. Now you want to use ES6 imports and exports. So, well, I need to now rewrite my code so that it uses our imports and output and exports. Let's do that. We know how to do that. So let's rewrite this so that it uses the newer way of doing this, right? So let's rewrite our controller. So instead of you doing this, okay, what we're going to do is that we're going to do an exports default export. So use a const examples controller equal that, right? And then we're going to export default examples controller. Okay. So this is more to the syntax that we're so familiar with. So same thing in the app.js, we're going to have to do the same thing. going to do, let's say, um, import express from express like that. And same thing here, import from that. So it's equivalent. It's just that it's a different syntax. So let's try running this. And, oops. Let's see. Before blah blah imported from yada yada yada. .js maybe? No, we have to add the .js. It's not smart enough to the .js. So let's try it out. See if it still works. So hello world. There it is. And let's add. And 6, 7. There we go. So looks like it's working. Okay. So, but now we can use the syntax that we have been familiar with for the last several weeks, right, or months. Okay. All right. Excellent. Yeah. So now that we know how to break out a few things, let's we can create other controllers. Let's create one for maybe tweets. So let's create here a couple of tweets. We'll say tweets controller. And so instead of creating a file, I'm going to create a directory, and we'll create here a index. And this will be the controller. And let's define the file with some another file, a JSON file containing. Oh, let's create another JavaScript file containing our tweets. This will be the tweets, and it's going to export default some array of tweets. This could be one that has ID of 3 and the tweet that says tweet. Let's see. Let's create a few of these. Okay. 4, 5. This is C. C. And okay. All right. So then a controller here is a const tweet controller function that is going to take as argument the express instance so that I can do things such as get. I can just do app.post, app.put, and app.delete. All things about tweets. I can retrieve tweets, I can create tweets, I can edit tweets, or I can delete a tweet. Right? All things about tweets. Okay. And the default data that I want to work with is the tweets that I can import from a local file, just tweets.js. Yeah. And so, for instance, if I ask for the tweets, if I ask for all the tweets, then I'm going to respond. I'm going to response. I can say, hey, response, send back all my tweets. See that? Right? So let's try it out. Let's try it out. Let's in our app.js, let's import the tweets controller. Tweets controller controller tweets controller. I'm not sure if I have to put in the index. Yeah, I think so. And then I'm going to say tweet controller So let's try it out. Stop this. Another app, there it is. So let's try it out. Oops, I think it died. Choose controller, blah, 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 blah. Syntax error, the requested module, blah, 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 blah. Does not provide an export. Ooh, did I forget to export? I think I did. Yeah, let's export default. Choose control. Let's try that again. Oops. Let's see. Index, yada, yada, yada. I cannot read property, blah, 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 like index. So it just didn't like that. Node modules, path, blah, 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 blah. Now read property, yada, yada, yada. So let's see what's going on. That. Directory import, blah, 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 blah. Imported. Not supported. Resolving, yada, yada, yada. Here's one imported, yada, yada, yada. Give me a tweet controller. Isn't that what I did? That's what I did, you know? Oops, what's going on? Node.js, blah, 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 blah. Path, modules, path, right expression, and now in properties I'm fine. All right, whatever. I think it's doesn't like the name index. I'll fix that later. No, what's going on? Controller, tweet controller, tweet controller, controller. Yeah, tweet controller, tweet controller, controller, tweet controller. Oh, I think maybe someone. Oh, okay. No, what was happening is that it didn't like it that it did not provide arguments to this. Yeah, so it wants to declare arguments to this, right? So let's give it some arguments. So tweets supposed to have an argument, function like this. So let's provide all these. There we go. That. Okay, there. So it's happy now. Yeah, it can't be just left 0 arguments. All right, so it's listening at port 4000 presumably, and if we say /tweets, presumably we should get the array of tweets here. I declare it here. Let's try it out. We say tweets. Notice that indeed we have an array of tweets. Okay. So this is going to be the main role of a server, right, of being able to serve data, right, and be the essential place where we can send, retrieve, update, delete data, right, in a central server from a client's point of view, right? So the client is going to generate HTTP requests, right, to retrieve the tweets, so to delete a tweet, to update a tweet, right, create a brand new tweets, as opposed to what it did earlier. Right? It used to load it up from a JSON file on the browser side, yes, but it could not manipulate it. It could not manipulate the data. It could render the user interface, but any modification that we did, right, they were rendered useless when we refresh the screen. All updates were gone, right? So, but now on the server, we have the option of, if you create a new post, we could edit the file, right? We could write this file or store it, insert it in a database, right? We do all sorts of things. Okay. So yeah, actually, let's do that. Let's see if we can create a new tweet. So for instance, I'm going to say request response. Okay. So how do we do that? How do we send data? Well, we already know how to send a little bit of data. For instance, how about what about if I want not all the tweets, but maybe I want some of the tweets? Maybe I want a particular tweet. How would I do that? Right. So before we get to post just yet, let's create another one of these. Okay. So for instance, what if I want to not all the tweets, but maybe I just want this tweet over here? I should be able to provide you with a particular ID, right? And then you retrieve that one particular tweet. Right? So we know how to do that, right? So we can encode as part of the URL maybe the ID of a tweet, okay? and then instead of responding with all the tweets, instead of responding with the array of tweets, maybe we can filter out which tweet matches the ID. Let's do that. Let's say const tweet ID. We can get the request. We can get from the params. So the params can retrieve the tweet ID, TID. And then we can find the tweet, the actual tweet that matches, by looking at all the tweets and then finding the tweet whose ID matches the tweet ID that we're looking for. And that would be the actual tweet object, right? Then we can send that one tweet object instead of sending the entire array, right? So let's try it out. Let's stop the server. Let's run it again. So here now, if I say instead of tweets, I can say tweet/234. Notice that now I only get tweets that once tweet, right? Or maybe you get the one with 5. Compared to asking now. Make sense? Okay. All right. So but how do we send a new tweet? How do we send a tweet? Well, that's a little bit too complicated. Right? Let's not do that just yet. Right? Let's wait that for a minute. Modify also is complex just yet. Let's do delete. Delete is not so hard. Not so hard. And so there's a few problems here. Well, first of all, we need to be able to send in the tweet that you want to remove, right? Because here you have all the tweets. You have all the tweets. You need to be able to say, well, you're not going to remove all the tweets. You need to determine which tweet you want to remove. So good thing to do would be that you would encode the tweet that you want to remove as part of the URL. Okay. But notice that a key now I might look at this and say, wait a minute, isn't there a collision of these URLs? Don't they need to be unique, right? That if you send me a get tweets ID, aren't you just going to retrieve that particular ID? How would you distinguish it from this over here? Well, yes, and then the response is that this is listening for an incoming get, and this is listening for an incoming delete of the same URL path or matching. Yes. So we need to be able to send from wherever we're sending a delete instead of a get. Unfortunately, the browser can only send gets, right? Well, at least from this here, right? This URL that I'm typing manually, I can only send gets. Right? There's no way for me to send a delete. How do we do that? How do we send? So to send the deletes, we're gonna have to use another piece of software, Postman. The Postman is an application that allows us to generate any HTTP request we want, unrestricted. Right? We can send whatever we want to anybody. Right? So let's do that. So I'm gonna create a collection here. Call it CS 5610 fall. So collections allows us to group together, a set of requests that we're playing around with, right? So this is what do we want to do? We want to send this URL. We want to access this URL, probably a particular URL, but right now it's responding to a GET. Right? And what's running? This is running, right? This here. But instead, we want to do something here in the delete. But it's the same URL. So let me copy that URL. Let me bring it over to Postman. Let's say here's Postman, right? And I want to generate I want to create a new request. Okay, request. There it is. By default, requests are GET. I'm going to say I want to generate delete. See that? And the URL is this one right there. That's the URL that I want to send. Just want to remove that first tweet. Okay. Right, so if I do that and say send, it says something wrong, cannot delete. Why not? I guess because probably this is this we didn't stop it. So let's stop it and run it probably. See. So now it should go in here. Let's see. We try it again. Send. Notice that we send a request, but it's not responding. It's like stuck waiting for the response. We never responded. Let's cancel that. So we could say here, send back maybe a request response. This response says sending something that deleting. Let's start the server again. If I try it again, send. Notice that indeed we are getting the deleting tweet. Okay, so we are hitting that function. We're definitely hitting that function. Which tweet? Oh, it's this one here, right? So let's grab that tweet ID from the request. Okay. And so maybe now we can specify which tweet we're going to remove. We're going to remove TID. Let's start the server again. We run again. Notice that says we are removing tweet 123. Or we're going to remove tweet 234. Yeah. So we are receiving that information on the server. Let's save that. Okay. So we should give it a name. We'll call it delete. Okay. All right. So how do we delete a tweet? How do we delete a tweet? So basically, we need to edit this array. Right? The problem with editing this array is that it's an import, and an import declares a constant. Right? So we can't edit that tweet, that this array over here. So what we'll do is that we'll declare an intermediate variable. Maybe we can call it this tweets array. Let's call this okay. Let's rename this. This is factor. Rename. This will be tweets array. Okay. Okay, whatever. Refresh. So tweets array. Oh my goodness. It's array. It's array. It's array. Okay, that's it. Okay. And so what we're going to do is we're going to copy a local variable called tweets. It's going to initialize it using tweets array. Right? Oh, put it back. Let's say tweets. That's it. Right? So tweets. Yeah, that's it. So basically, we are using a variable now as opposed to a constant that we just initialized to be what we loaded from the file. Right? So once we load it from the file, we can then edit it So for instance, one of the things we might do when we delete is that we can say, let's recalculate the tweets so that it's the same tweets minus, we're going to filter out the tweet, right, that we don't want to keep. Let's say we want to keep only the tweets whose ID is not, right, the tweet ID. And so now we have removed that tweet from the tweets. Okay, and we can respond saying, okay, we did it. Right? We can send a 200. So if you send an integer as a response, then it understands it as an HTTP code, like 404 means I didn't find something, right? And 200 means okay, everything's good. So for instance, let's try it out. Let's stop this, stop running, and let's now send the delete 234. So first of all, before we do that, let's make sure that we have all our tweets. These are all tweets. Those are 3 tweets, and we want to remove 234. Presumably, we want to remove this tweet over here. So we're going to end up just with 1, 2, 3, and 3, 4, 5. If this works, let's try it out. Let's send. We get an OK. There it is. That was our 200. If we go back here and I refresh my browser, notice that indeed we only have 1, 2, 3, and 3, 4, 5. See that? Notice that now if I refresh the server, this is going out. Notice that it always comes back with the same data. So we have finally made something a little more permanent. Not quite totally permanent, but it is more permanent than the browser solution that we've seen so far, right? And I said almost permanent because if I stop the server and I start again, it's going to reload that file, right, of those server tweets that are stored in that file. And so that if I ask for the tweets again, notice that I have my 3 tweets from before. So to make it really, really permanent, we would have to write the tweets back to the file, right? We need to update that file. Or what we're going to be doing tomorrow, next week, right? We're going to be using a database, and the database is for making permanent changes, long-lasting permanent changes. Okay. So this week we're just learning how to do things in memory, modifying arrays and things like that. Right. Next week we're going to make it much more permanent using a database. But is everybody still with me? Okay. All right. So we can delete the tweet. This query here that we're doing this get of retrieving the tweets, we should also move it to our Postman. Create a brand new request, right? And it is a get. That's good. Let's do it as a get. And the URL is just tweets, and it is a get. We'll call it find all tweets. Say that we're going to send, and it comes back with the 3 tweets, just like this, just like that. So right now, then I don't need the browser anymore. I can just use my Postman. I can also find a tweet by its ID. So I'm just going to duplicate this, and I'll call this find tweet by ID. If I provide a particular ID, I have to save that. Oops, save. And send. Notice that it retrieves that one ID. Right. So now I have a few things now that I can try it out right here in my Postman instead of using a browser. Browser only allows me to generate these gets, right? But a Postman allows me to generate much more stuff. The deletes, the posts, the puts. Let's create a post. We're going to create a new tweet. So how do we do that? So to do that, we're going to use post. Okay, and it's a brand new post, so we don't even know its ID. And so we're going to receive the maybe the body. What we're going to do is that we're going to send the body, the JSON data from the client. We're going to send it over, and in the HTTP body, right? Remember I said there was 3 ways that we can send data: either encoded as a URL as part of the path, The second part is included in the body, in the HTTP body. And the third one is query strings, which we'll see a little later. All right, so here we can say we can retrieve that data of the new tweet in a JSON object that is embedded inside of the HTTP request from the body. So we can say const tweet, new tweet, being the request body. Okay. And basically what we're going to do is that we're just going to append the tweets.push and add the new tweet at the end. Okay. And then we're going to send back response dot send back a 200. Yep, got it. You have it. So on the Postman side, what we're going to do is that we're going to let's duplicate this one. Duplicate. So this one over here, it's going to be a post. That's what we're expecting on there, right? The URL is the URL, meaning it ends with /tweets. Okay. But we're going to send in as part of the body, right? Let's rename this. Let's create. As part of the body, right? We're going to include some raw data that is formatted as JSON, and it's going to look something like this. So we have the tweet, and we'll pass in some data. Run by Twitter, the real Twitter. Oh, because it applies our Twitter. Yes, let's do that. Let's do a send. Let's see what happens. Okay, it looks like it didn't work. Probably because we didn't restart the server. Let's restart the server. Let's try it again. Send. Okay, it sends back an okay. Well, looks like we were able to add a tweet. Let's see. Find all the tweets. There were 3. Send it again. All right, looks like our 4th that was added was null. Now, the reason is that the body that we sent in was looks like this was null. So the body was null, and so it appended a null to the array. So that's not what we want. So for this to be able to work, we need to tell the Express how to read JSON from the HTTP body request, right? So we do that in the setup here. So so what we can do here is using this app, we say use a parser that knows how to parse JSON from the HTTP body, right? And that's inside the express.json. Okay, that is a parser that if you call that function, it returns a JSON parser. And so we're going to tell Express to use this browse parser, right, for every request. Just like we can say, what to do when we get a get, if we get a post or if we get a delete. We can also say for all of them, whether it's a post, a get, or doesn't matter, for all of them, if there is JSON data in the body, parse it out, right? For all of them. So the way we do that is by saying app.use. App.use is a catch-all, right, that says for any request, whether it's a get, a post, a put, a delete, always use this JSON parser. Parse it, and then once you parse that, make the data available in the body attribute so that somebody can pull it out. So let's try it out again. Let's run the server again. Let's try this again. So let's get all the tweets. Let's send it again. Okay, we got our first 3 initial tweets. Let's create a new tweet again. Send. It says okay. Let's go to find all. Send. There it is. See that? We got something missing though. Right? We got the data in there, but we don't have an ID. And we could send it in here. We could send the ID here, but this is data that the client would be sending. The browser, that makes no sense. Instead, oftentimes these ID are calculated by either a database or something like that, right? So let's simulate that. On the server side, in this here in the post, let's add to new tweet a make-believe ID. I would say new tweet. Eventually, this will be created by our database. Okay? So if we don't have that just yet, that'll be next week. So we're going to say dot is equal to say new date dot get time. We convert that into a string and an empty string. So now this whole thing is a string, and then it gets pushed in there. So let's try it out. Let's run the server again. Let's try this out again. Final tweets is just have the first three, and we'll post a few times. So 1, 2, 3. Let's go to final tweets. Refresh, and there it is. Right? We have the Elon. Right? Instead of making the mistake of buying Twitter, should have bought Twitter. There we go. So we're able to append 3 of these, or we can delete them, right? And so for instance, this one, go delete, the ID, say send, and it sends OK. Let's get all of them, see if it's gone. There we go, it's gone. Let's remove another one. Delete. And here's the ID. Send. It's gone. Let's find all, make sure it's gone. Yeah, it's gone. And then we can delete this last one. Right, say send. And we can find it. Okay, that one too is gone. Okay. All right. How about modifying a tweet? I want to update a tweet. So for that, right, we're going to use put. Right. So we're going to first encode the ID of the tweet that you want to manipulate. So the ID is part of the path. The new updates are going to be in the tweet updates. Are going to be in the body. We're going to send in what we want to change. Now, it might be that you have a lot of fields in a tweet, and we don't want to modify all of them. Right? We might just subset. Okay. Let's see the question in the chat. Where is the JSON parse actually happen? So the JSON parsing happens before, right? When the requests come in. When the requests come in, before it gets to any of these, right, in that order. So for instance, if this app.js, notice that this is being declared before these controllers. See that? So this gets to declare first before these two. That means that when the requests come in, they are consumed or they are processed in the order that these .get, .use, .put, .post, in the order that they are declared. So that means that the very first thing that happens to the request that comes in, the first thing is that is handled by this middleware, right? It handles it. The request comes in. It JSON from the body. It comes in as just plain text. Right, so express.json interprets that text as JSON, right, and puts it in the request body, and then it lets the request continue. Right, then all these two get a hold of the request, right, and compare. So this one compares it with hello, compares it with goodbye, compares it with all these patterns. Right, when it's done, then it's the tweets control's turn. Right, then it compares it with tweets. Tweets ID, blah, 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 compares it to all these. And the one that matches, it runs that function. Right. The last one does a send. When it gets to a send, then the response goes back to the client, right? It does not continue to be processed by any further get or post or anything. It's complete, right? It goes back. Where's at some point? Where you, yeah, we'll do that. Is app that use like a middleware? Yes, absolutely. Thank you, Dennis. Yeah, it's middleware. Perfect. All right, so put. We're gonna get the tweet updates, and what we're gonna do is that we're going to replace the particular tweet, right, with the updates. And there's a couple ways of doing it. It is an array. We could find, where is it, what element in the array it is. We could say maybe const tweet index. Say tweets dot find index tweet, so that if the tweet dot ID matches the tweet ID, which we don't have. Right, so let's do that. Let's grab the tweet ID from the parameters. Request.params.tid here, right, TID. And we're comparing it with TID, so this finds where in the array. Once we have the array, we can say please sub tweet index, right, equal to what? Well, we can just replace it with what the updates are, but really, it might be that tweets has like 20 fields, right? But I only want to update 2 fields, maybe the tweet and maybe the likes. Right? But the actual tweet that we want to update has 20 fields, like how many likes, whether I liked it, how many replies, right? Whether it has been retweeted, right? All sorts of questions, all sorts of things. Who their username is, who tweeted this, when was it posted, all sorts of things, right? So it'll be a merge between the two, between the old and the new. So the way we do that is by using dot dot dot. Right? We can copy over the old ones, the old tweet, tweets sub tweet index. So let's copy the old ones, the old tweet, but then let's override any fields with the updates, right? And then we can say response.send 200. Now here, this index could come back as negative, if it did not find it. If we didn't find it, we'd say, if tweet index then or 0, then we do this. Right? Else, we did not find it. The tweet that you're trying to update was not found. So we can say response sent back at 404. Say nope, we didn't find it. Same thing with delete. We do the same thing here, right? First we find to see if that ID is found in the array. If we find it, we send back at 200. If it's not in the array, then we can send it 404. Okay. So yeah, so let's try that. Let's restart the server. Turn again. And so let's update here. Let's duplicate this post, and it's going to call update tweet. It's going to be a put, and let's modify the first tweet, right? And body has not changed in the tweet itself. You could say maybe likes, and what's 1,000. So we can say put blah 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 blah. We say send. Okay, came back with an okay. Let's find all the tweets. Okay, this one, notice that there should be a likes there now. Send. There it is. See that? Likes 2, 3, 4, 5. Okay. Now the update, if I use a wrong ID, 1, so then notice that it comes back with not found, right? A 4 or 4, it's a not found. All right. All right, excellent. Yeah, so there it is. We have a server that can store information about tweets, update, delete. The next thing would be, how do we integrate this server with the React application that we've been playing around with? Right? The React application has been using reducers and has been doing state management and whatnot. But now we're going to be moving all that state management to the server. So instead of being the client who maintains the state is now going to be maintained by the server itself. Right. So we'll talk about this next week we meet. We're going to see how to integrate with this from the client's point of view by moving the state management to the server as opposed from the client. We'll still be using reducers. We'll have to modify the reducer so that it can interact asynchronously with the server. So that's going to add some complications, some really interesting communication between client and the server. All right. So anyway, that's all I had for you. Any questions? All right. If you don't have any questions, let's see what else. I will be making the exam available. I do owe you some points from maybe a couple of questions. Maybe I don't know. If you come back with some feedback that there was some misspelling or there's some errors that you might have found, please respond to that. I'm not making it available just yet. I can't because I have a couple students that have not taken the exam just yet. So once they're done, I will make the exam available. Again, as always, please reply to the post when I make the exam or answers visible, right? So that I can go back, maybe fix a few things and give some points back or whatnot. Okay. Yeah, they're not just ready just yet. Again, tomorrow at 8, I will have my office hours as always, and looking forward to seeing you then. All right. Good night, everybody.